Hi Professor, my name is Kumudini and this is my submission for Lab 5 of DPS912, Processing Signals and System Monitoring. So in this video, I will be walking you through what the lab does, how I implemented it, the challenges I faced, and my self-evaluation at the end. So let's get right into it. Okay, so the goal of this lab was to build a mini system monitor that uses Unix signals as the only method of communication between processes. So we have one parent process called sys monitor execute and two child processes called intf monitor. Each child monitors a network interface. One monitors LO, which is the loopback interface, and the other monitors ENS33, which is the Ethernet interface. So instead of using pipes or shared memory, all coordination happens purely through signals. The parent sends SIG user 1 to tell the children to start, waits 30 seconds, then sends SIG user 2 to tell them to shut down. The children also handle Control C and Control Z by simply discarding them, so they can't be interrupted from the keyboard. All network statistics like bytes sent and received are logged into a file called network.log, as you can see. So let me show you the program running live. Firstly, I will clean my make so that I can run make all now. So to compile both the executables, I run make all, and as you can see, it compiles cleanly with 0 warnings. Now I will run ./sysmon exec. So you can see the parent process starts with its PID, then immediately forks two children. Each child calls execlp to replace itself with the intf monitor program, one for LO and one for ENS3. The parent sleeps for 10 seconds, then sends SIG user 1 to both children. You can see both children print intf monitor starting up. That confirms they received the signal. So after 30 seconds, the parent sends SIG user 2. Both children print intf monitor shutting down and exit cleanly. The parent's wait call reaps both children, prints their exit status, and then the parent itself exits with the finished message. And if I now open the network.log file, we will be able to see that we can see 30 lines of statistics for each interface recorded every second. So now let me walk through the code. So starting with the intfmonitor.cpp file, so this is the child process, right? So at the top, I declare the signal handler prototype. This is required in C++, so the compiler knows about the function before main uses it. So inside the main, I declared the sig action struct. So I prefer sig action over the older signal function because it gives precise control and is more portable. I set sa.sa_handler to my sig handler function and I register it for 4 signals: sig user 1, sig user 2, sig int, which is control C, sig tstp, which is control Z. Then the child enters a while loop called pause here. So pause suspends the process until any signal arrives. Once SIG user 1 arrives, the signal handler sets is running to true, the loop exits, and monitoring begins. The main monitoring loop reads 4 statistic files from /sys/class/net, tx bytes, rx bytes, tx bytes, and packets and rs packets, and writes them to network.log every second using snprintf for safe string formatting. The signal handler at the bottom handles all 4 cases. SIG USR1 sets is running to true. SIG USR2 sets it to false, which exits the while loop, and SIG int and SIG TSTP just print a message and return effectively, discarding those signals over here. Now for sysmonexec.cpp, let's look at the parent process. sysmonexec.cpp. So here we have our parent process. So the main forks twice using a loop, and each child calls execlp to execute the intf monitor program with the interface name as an argument. In system monitor, the parent loops through child PID array and calls kill with SIG user 1 to start all children, sleeps 30 seconds, then calls kill with SIG user 2 to stop them. Finally, it calls the wait function in a loop to reap all children before exiting. This prevents zombie processes. So here it sleeps for 30 seconds, then calls kill, and then it finally exits. Now, talking about the challenges I faced during this lab, the first was compiler warnings. The original code used character star for string literals, which modern C++ does not allow. So I fixed it by adding the const keyword to my file. The second challenge was understanding the pause call and signal interaction. I initially wasn't sure how to make the child wait for SIG user 1 without busy waiting in a CPU heavy loop. So using pause was the right approach. It puts the process to sleep with 0 CPU usage until a signal wakes it up. So for my self-evaluation, I believe I've implemented all the requirements for this assignment. I would rate myself 9 out of 10 for this assignment. I completed all the functional requirements and fixed all compiler warnings. The one point I leave off is because I'd like to explore more robust error handling. For example, checking if the network interface actually exists before trying to read its statistical files. So thank you so much for watching my video. This marks the end. Thank you.